So in section 4.7, there's two different kinds of equations that we need to be able to write given 2 points. One is an exponential, which is y equals ab to the x. The other is a power function, which is something in the form of y equals ax to the b. So the first examples I'm going to do are the power functions because they are the more complicated ones. For either the power functions or the exponential functions, we're going to need 2 points. And the way we do them is we substitute in the x and y values for those points and then just solve using algebra and our properties of logs. So I'm going to write 2 equations. Y is 1 equals a, x is 2, so 2 to the b. Then I write my second equation. I get 6 equals a 7 to the b. What I'm going to do here is I'm going to solve my first equation for a and then substitute it into the second equation. Solve this equation for a and then substitute it in the second equation. So I solve this one for a, I get a equals 1 over 2 to the b. Any questions on that? Now what I'm going to do is I'm going to merge those 2 equations together by substitution, stuff we did in Algebra 1. Just substituting for things that are equal to each other. So that gives me 6 equals 1 over 2 to the b times 7 to the b. And I can rewrite this as 7 to the b over 2 to the b. Any questions on how I converted from this to this? So I know 6 is equal to that. Well, right now I have exponentials, and the way I can go to solve things that have variables in the exponents is by taking logarithms of both sides. So what I want to do is take the natural logarithm of both sides of this equation. So on the left-hand side, I get the natural log of 6. On the right-hand side, I get the natural log of 7 to the b over 2 to the b. But I can rewrite this as a subtraction problem of logarithms. So that's what I'm going to do. I'm going to put equals what this is. Because we know a division property of logarithm says, hey, rewrite this as a subtraction. So I now have the natural log of 6 is equal to the natural log of 7 to the b minus the natural log of 2 to the b. We know if I have logarithms with something with powers, I can pull those powers down in front. So that's what I'm going to do. I'm going to write natural log of 6 is equal to b, natural log of 7, minus b, natural log of 2. Each term on the right-hand side has a b, so I can factor that b out. That's what I'm solving for is b. So that gives me natural log of 6 equals times the natural log of 7 minus the natural log of 2. My final step solving for b is to divide both sides by what's in the parentheses. Natural log of 6 over natural log of 7 minus the natural log of 2. And our calculator, rounded to 3 decimal points, we get approximately 1.430. And if you're not here in class, what you need to do is actually work this in the calculator until you actually get that number. Make sure you're entering it in the calculator correctly. Now that I know what b is, I can stick that b right here and figure out what a is. So a equals 1 over 2 to the 1.43. So I'm going to go 1 over 2 to the 1.43. And I get approximately 0.3711. We now know what our a is. We know what our b is. So we can write the equation in this form. Y equals 0.3711 x to the b, 1.43. So this is not a quadratic. It's not a cubic, but it is a power function. Okay? It just happens to have an irrational exponent. In this case, it's a rational exponent. But that's how we can come up with the equation of a power function that goes through those 2 points. I'm going to do one more example and then set you free to work the last example. Then I'm going to do the work and see if you get the right answer. Then we'll do the easy ones, which are the exponentials. So, y equals a to the x. First thing is to substitute in for y and x. So I get 4 equals a 3 to the b. And I get 15 equals a 6 to the b. Solve one of the equations for a. I'm going to solve the top equation for a, and I get a is equal to 4 over 3 to the b. Substitute. I get 15 equals 4 over 3 to the b times 6 to the b. So let's look at this 6 to the b. What's a way I can rewrite 6 to the b that's going to help me? So would you agree that 6 to the b is equal to 2 to the b times 3 to the b? Isn't 6 squared equal to 2 squared times 3 squared? That's 36. 4, that's 9. 4 times 9 is 36. Okay? So notice that 6 to the b I can rewrite like this. Notice I have a 3 to the b in my numerator and my denominator. What's going to happen with those? Any number divided by itself is what? 1. So these cancel. So I now have that 15 is equal to 4 times 2 to the b. I need to get the exponential by itself. So my one step to get the exponential by itself is to divide both sides by 4. I need to be able to get to that exponent. The way to get to exponents is by taking logarithms of both sides. Taking the natural log of 15/4 equals the natural log of 2 to the b. If I have a logarithm with powers, that means I can bring the power down in front. And to get b by itself, I divide both sides by the natural log of 2. And we stick that into our calculator, round it to 3 decimals. So the natural log of 15/4 divided by the natural log of 2. Approximately 1.907. We are going to take that and we are going to now solve for b. Actually, that's our b. We're going to now solve for a. So this number that I have in my calculator, I'm going to use in this equation. So a is approximately 4 over 3 to the 1.907. So I'm going to hit 4 over 3 to the answer and I get approximately 0.492. So final answer, y equals 0.492 times x to the 1.907. Any questions on the work for guided practice 6? Go ahead and try guided practice 7 on your own. Then I'm going to go through the work. So 2 ways to do this problem. First thing you're going to do either way is you're going to substitute in your x and y's for both points. So you're going to get 8 equals a to the times 5 to the b, and 34 equals a times 10 to the b. One way to do this problem is solve the first equation for a, and then substitute that a into the second equation. If I do that, I get a equals 8 over 5 to the b. I substitute it in here, I get 34 equals 8 times 10 to the b over 5 to the b, which is equal to 8 times 2 to the b. Divide both sides by 8. So I get 34 eighths equals 2 to the b, or 17 fourths is 2 to the b. The other way to do it is to solve both of these equations for a, then set them equal to each other. If I set them both equal to a, I can then set 8 over 5b equals 34 over 10 to the b. Do my cross, bring the 10 to the b up here and the 8 down here, and I get 10 to the b over 5 to the b is 34 eighths. Simplifying the left, I get 2 to the b. Simplifying the right, I get 17 fourths. So in either case, I get to 2 to the b is 17 fourths. Take the natural log of both sides. I get natural log of 17 fourths is natural log of 2 to the b. Bring the b down in front, and I get natural log of 17 fourths is equal to b natural log of 2. Divide both sides by the natural log of 2, and you get b is the natural log of 17 fourths over the natural log of 2, which is 2.087. Substitute that b into either one of these two equations. I substituted it into 8 over 5 to the b. So I typed in 8 divided by 5 to the answer, because this was the answer I had in my calculator, and it gave me approximately 0.278. So there's my a, 0.278, and my b is 2.087. Again, I started with the harder ones. Power functions are the harder ones to do because you end up having to take the logarithms of both sides. When we write our exponential functions, they're going to be a little bit easier. And that's going to be the guided practices 1, 2, and 3, which are at the top of the page.